So a data mover is essentially a Spectrum Protect client running with specific options in its option set. And there's a few settings that you have to go through in order to get that guy working properly to behave as a data mover versus just a traditional file client scheduler. So I'm going to go to the Spectrum Protect client installation directory. That's in that directory there, opt Tivoli TSM client BA bin. We'll see in here all the necessary files, specifically DSMC as being the commands that you would use to execute various Spectrum Protect backup commands. All right. So we see we have a whole bunch of DSM files. I have some older ones in there, but the dsm.opt and dsm.sys files are the ones we're going to look at. So you'll need to create those. Those won't exist initially. When you create them, in the dsm.opt file, this is what you'd want to make to set up your data mover. Simply one line, and it's going to say server name, and then it's going to have a stanza name. They call it a server name, but it's really a stanza name. I have it set to just server 1, which is basically the default. That simply tells the client which stanza inside dsm.sys to reference. Now in our dsm.sys we only have one stanza, so this parameter is really irrelevant, but setting it allows us to be clear about which one we are executing. Or if we wanted to create multiple data movers, which we can talk about later, you'd build multiple options files, each with the different stanza referenced, and then the sys file would have each different stanza located inside of it. So I'm going to open up dsm.sys, and we can see what is needed in order to get a data mover to work. Okay, so some of these things you'll probably recognize from a normal client configuration. We have a node name specified, and you'll notice the node name is VM Data Center DM. So that is specifically called out. If we don't call the node name out, the node name is by default going to be the host name of the machine, and in this case that's TSM server. We don't want to use that. Excuse me, TSM server 1. So we don't want to use that as the name. We want the node name to be VM Data Center DM. The reason for that is that that is what we specified here, and that's also what is configured over here. Hopefully that's legible. So that's what our VM Data Center data mover name is. Okay, so let's jump back. And the password access generate is necessary, obviously. And VMC host. So this is the VMware vCenter host that we're referencing. We'll see I'm calling out the vCenter host there by name. The backup type is going to be full VM. So this is a parameter you need to specify in order to get VMware to work properly, or for the VM-based backups to work properly in full VM mode. That's the mode we want to use. The other option would be a setting specifically for Microsoft virtual backups. Managed services, schedule web client, that's something you'll see pretty commonly. That means that the DSM client acceptor daemon is going to control both the scheduler service and the web client services, the agents, essentially the web client agents that will run. They'll get spawned as necessary when services need to execute. Then we'll see here the TCP server address. That's pretty self-explanatory. We have the TSM server name specified there and the default port for that server. COM method obviously is IP. And the client address is also the same IP DNS name here. The reason for that is all these processes are all running on the same physical host. Now if you ran your data mover and your Spectrum Protect for VE on a separate box somewhere else in your environment, let's say it was a virtual machine in your VM farm, this client address would obviously be different. And schedule mode we want to set to prompted. Prompted gives us the best performance and the best immediate response whenever we're executing schedules. The least likely scenario where we avoid those issues where clients don't necessarily execute because the polling process takes too long to pull, and a backup could possibly get missed. I think the default for polling is 12 hours, maybe it's 6 hours. And that means that if you make a change within that 6-hour period before a backup happened, you may not actually get the backup to run. So I like to use prompted. Prompted is pretty common nowadays. It requires the server to contact the client to issue a backup. I specify my SCAD and error logs, but those are the default locations. And I also make sure I set up retention, SCAD and error log retention, set it to 30 days and delete the file after 30 days. Delete anything older than 30 days essentially out of the file. That's very important to do. These logs can get very big. You don't want to have these logs overrun your file system, and they will do that. Now down below here I have a selection of some of the VM specific options and what those options might do for you. I'm going to walk through what these all are and how they potentially may impact your DataMover, and you may choose to set some of these or not set some of these. You'll see I have only a couple set. Most of them are commented out. Usually they're not needed, but in specific scenarios you may need them. All right, so VM tag DataMover. Now that's the key one right there. For we're talking about tag support. We have to turn on VM tag DataMover and set that to yes in order for this DataMover to behave as a tag-enabled DataMover. So a DataMover has to be either a regular DataMover or a tag-enabled DataMover, and this one is set up to be a tag-enabled one. That second parameter there I have set to yes is VM enable template backups. The default is no. Same thing with VM tag DataMover. The default is no. That's why I'm specifying them. We want the template backups to be enabled because I do have a few templates in my VM environment and I want to be able to back them up. If you turn that on and a template is called or referenced in the tagging, it'll just get backed up like every other VM. All right, now below that we see VM tag default DataMover. So this is pertaining to a added functionality they introduced in 8.1 that allows you to have DataMovers that somewhat coordinate amongst themselves during a backup. That coordination means that we need to have a default or a central DataMover that catches backups that aren't specified to any specific DataMover. If we don't have any DataMover specifically called out for a given VM object, it'll fall back to the default DataMover. So if you set this parameter VM tag default DataMover to yes, what you're essentially saying is this DataMover, the one we're configuring here, is the default DataMover. So if a VM backup runs and there is no tag to specify the DataMover for a given VM, that tag or that parameter will make this DataMover as the go-to guy. I don't have that enabled right here because I only have one DataMover and it's the only DataMover that I'm going to be using. All right, so the next one is the megablock % refresh threshold, and the second option there is related to that, megablock object refresh threshold. Those parameters, the defaults are both 50 objects or 50%. Those parameters are used to adjust how frequently VMware rebuilds megablocks. A megablock is 128 megabyte chunk of data that is transmitted from the VM backup to the backup server. Adjusting these parameters sometimes can improve restore performance or cut down the number of objects that may exist for a given VM inside the backup server. The more objects, the longer potentially it may take to rebuild the backups when you do a restoration. So trying to fine-tune these by adjusting these generally, setting the thresholds lower will reduce the number of megablocks. It'll increase the amount of data that gets sent each night because it'll be easier for a megablock to be triggered to be resent, a large chunk of data. So adjusting it too small could potentially create a situation where more data is being transmitted to be backed up every night, and that may not be advantageous for you. But at the same time, that may help cut down on object count, which may help your performance. The defaults generally, like I said, are fine, but you may have cases where object counts seem to be high for a given VM or a given group of VMs, and you may choose to make some adjustments for those. All right, so VM max parallel, VM limit per data store, and VM limit per host are all related commands again as well. VM max parallel is how many parallel VMs can be backed up at once with one DataMover. By default, the parameter is set to 1. That essentially turns off parallel VM backups. That means that VMs are going to be backed up in a sequential order through one data mover. So we could adjust that to allow 2, 3, or 5, or however many we so deem necessary, however many VMs we want to back up in parallel. We can do that by adjusting that parameter. I'm leaving the default. Again, all these parameters I have highlighted here are the default parameters. So you could adjust that parameter, let's say, to 5, which means that 5 VMs at once may potentially back up out of the pool of VMs that are being requested to be backed up at a given point in time for this data mover. That may be a great way to improve performance if you have a large environment, lots of separate data stores outside in your VMware environment. You could potentially turn this up and help optimize some data ingest through the data mover. Most folks are being pretty commonly turning that parameter up, but given the small size of my environment, it's not necessary to turn it off the default of 1. The 2 parameters below that, the limit per data store and limit per host parameters, those parameters have to do with how many VMs at once can be serviced for a backup from either data store or a given host. The default setting is 0, which means ignore it. So what that means is if VM max parallel, let's say, was set to 4, and there were 4 VMs on a given data store, the data mover would be free to gather all 4 VMs at once from that one data store. Now we may want to set that parameter maybe to 1 or 2 to limit the amount of I/O coming through a specific data store so as not to saturate it and potentially affect production data or production access to the systems. So VM, if you were to turn on max parallel, you probably would end up turning on those other parameters by setting them to a relatively low value, depending on how much workload you can put against each data store or per each host. Now some hosts are pretty beefy. They might be able to handle several parallel operations, but you may want to have less so on the data stores if, say, your data store disk is very busy. Large enterprise disk arrays, maybe not such a big deal. Certainly if you have flash, solid state storage, that's probably not going to be a big deal either. But again, VM max parallel, you set that to something greater than 1, and then you probably set your limits to some type of value other than 0, and that'll help improve parallelism during backup. You'll see more than one backup job being serviced at once and data flowing across more than one thread, essentially, from the Spectrum Protect backup server, the data mover, back to the Spectrum Protect server. Okay, so VM default network and VM default virtual port group, default virtual switch, those parameters are all related to, in the event of a restoration, if some of this infrastructure doesn't exist, those port groups, networks, virtual switches, if those don't exist in a restoration environment where the infrastructure for VMware is still unbuilt or is simpler or lacking some of the more complex aspects of VMware's virtual networking infrastructure, you can specify what you want those devices inside a VM to be restored to, so as to not lose your VM network objects. Because if you don't have the appropriate network to attach to, the behavior during restoration is to drop the given interfaces, which could cause a headache when you're trying to restore. If your back-end network is not there and you've lost the interfaces, you may have lost some configuration that you may need to use, may need to have access to be able to see how to lay out your network attachment on your VMs. So these parameters allow you to have a fallback network that everything will get attached to, or a fallback port group or switch that everything can get attached to, so that even if it's not necessarily attached to the right thing, at least it gets attached to something and it still exists at the end of the restore. Again, we're not restoring here, we're just doing setup, so I won't be setting any of those. The VM data store threshold. Okay, this parameter allows you to control the kind of a forecast, if you will, before a backup starts. That parameter will be looked at, and if that parameter is set to something other than the default's 100, it's a percentage. If that value is set to something less than 100, what that's essentially saying is at least that much space needs to be free. Let's say we set it to 90%. At least 90%, I guess technically 89% of the disk has to be there has to be like a 10% overhead gap that's available on a given data store to allow there to be room for snapshots. When VMware backups occur, a VMware snapshot's taken, and during the duration of the backup process, that snapshot creates a snapshot file which adds space to a given data store wherever a specific volume exists, well, virtual disk exists. So if you turn on the VM data store threshold and let's say set it to 90, what that essentially means is that unless 10% of your free disk space is available on that data store, we're not going to try to run a backup against that VM. We'll send an alert saying that it was unsuccessful to back it up because there was insufficient space in the data store. That parameter can save you from a situation where a snapshot is taken and a data store runs out of space before the backup completes, and you can have a virtual machine halt essentially because it runs out of capacity, runs out of ability to write changes down to the disk. So that can be a very important parameter. Again, we're not restoring here, so I'm not setting that parameter up. VM process VM with PRDMs. So RDMs, obviously raw device mappings. That's physical raw device mappings. The default is no, don't process those VMs, which means if a VM has a physical device mapping RDM, that VM is not backed up at all and an alert is sent. You can choose to change that to yes, which means it will process the VM, but obviously the RDM cannot be captured since VMware doesn't own the blocks. Those blocks are strictly controlled by the guest OS, and there's no way to access it via a VMware backup. So you'll have to use another mechanism to protect those RDM objects, such as a client running directly on the virtual machine, a traditional client agent. VM Max virtual disks. This is an important parameter for folks who are building larger VMs that exceed the 2 terabyte VMDK size. If you do exceed the 2 terabyte VMDK size and you want to back those VMs up regularly, you have to come in here and adjust this parameter. The default is 2 terabytes. The maximum parameter is 8 terabytes. And those 8 terabytes are the largest a VMDK can be and have Spectrum Protect for virtual environments be able to back it up. All right, so VM Timeout. So VM Timeout is a parameter that if you so chose to set up a backup of a box that's highly transactional, VM Timeout is going to give you a period of time to wait for your snapshot to clear. So normally when snapshots are being executed, there's a VSS command that is executed, and that VSS snapshot requires some orchestration on the client side, on the guest side of the OS within the VM. That all has to complete and give a clean, okay, we're all set for VMware to finally take its snap. That period of time between when the snap is requested and VM saying yes, it's good to take the snap can be a maximum of 180 seconds by default. If you have VMs that need longer to take their snaps and you're having snapshot failures which will result in a failed backup, you'll have to adjust this parameter, increase this setting beyond 180 seconds to provide some additional time for that snapshot to execute. And then finally, in the commented out list here, we have VM store transport. So basically what that is what transport method do we prefer to use when we're attempting to access the VMware storage areas. So the data stores, as it were. The VMware transport normal operating process is to attempt starting at the first parameter here, SAN, then try using a hot add, then NBD SSL, and then NBD. That's the order it's going to go in. Obviously, SAN is optimal because it's the fastest. Hot add is excellent as well because it means local, it means internal. That only works obviously when a DataMover is inside the VM farm. NBD SSL and NBD are the last resort fallbacks, are the final methods to try to achieve access to those data stores, and those perform comparatively fastest to slowest, essentially. Well, slowest and then less secure and slowest. There's not really a need to change these unless for some reason you want to specifically avoid using SAN even though it's configured to be set up. In other words, the data stores are presented to the backup server. In our scenario, everything's via NFS, but we're not presenting the data stores to the backup server, so it will probably be using hot add, I believe, during the backup job because the box is a VM. Oh no, I take that back. It'll be NBDSSL because my backup server and my DataMover reside on a separate physical machine, a non-virtualized machine. And then this content down here is the secondary server, server 2, and its IP address for my replication server. So that's the DataMover's dsm.sys file. This is the parameters that I have set up for this. Hopefully you guys get some value out of me reviewing all these different parameters and what they potentially can do for you. You might see cases where you want to set them up for yourself as you go through and build your DataMovers. So once we have that dsm.sys file set up and we already know that the dsm.op file is configured, then our next step is going to be to make sure that our passwords are all synchronized. There's multiple passwords that need to be set up. So when you set up password access generate in a traditional backup archive client, you have to run the client once and it'll prompt you for the password, and then it'll be saved into a password file on the local machine, encrypted, and it'll be served out every time a scheduled operations run. And that helps you avoiding having to log into the backup server every time a backup job runs. That's obviously a big pain in the butt. So what we have is the passwords need to be set, but there's additional parameter that, or additional password that you may not have thought of that need to be set up as well. The DataMover, when executing, it has to be able to execute commands against the virtual center server to issue the snapshot commands and to issue create backups, create data VMDK files when it's restoring, things like that. Those types of things need to be able to be called from the DataMover. So the DataMover has to have the password set to go into the virtual center interface. So in order to make that happen, you have to execute a command. And I'm going to have to look it up because I don't recall the command off the top of my head. So give me one moment. Okay, so the command we're going to run to set the password is like this. We're going to start by running just a normal DSMC login, and normally you'll see a password. I don't think we're going to see one here. Maybe I can delete the... All right, there's our password file. I'm going to remove that guy. And now when we run DSMC, we're going to run -asnode equals VM underscore data center. Remember, that's the name where all the objects exist. We want to log in as that guy, even though we're attaching as a DataMover, and this is the way the DataMover behaves. It comes in as the DataMover, but it's pretending to be the data center user or the data center node so as to have all the file objects attached to data center. It's backing up in behalf of the data center node. So you see it asks for a password, or a username, excuse me. So the username is going to be VM data center DM. I'm not going to change that. That's extracted from the dsm.sys file. And then it wants to know the password. The password I have set is nice and simple. There we go, and it tells you it's accessing as node VM data center. So you know that you're logged in. Even though you're connected using the DataMover node, you're accessing the content that's under the VM data center user, or node, excuse me, within TSM. All right, but we have another step we need to do beyond that, and that step is to set the password for Virtual Center inside that password file. So to do that, we're going to run this next command. So it's dsmc set password -type equals VM, and then we're going to pass the vCenter name, which is, what is it, vCenter? Yeah, okay. There we go. And then we're going to pass the user. Remember, this is the user for vSphere, and the password used for that, just like that. So this is going to set the password inside that server, or inside that tsm.pwd file. There we go. So now if we do this, we'll see that password's there. You can see that it's bound to the TDP VMware group, and that's important because obviously TDP for VMware user is going to be logging in and accessing that password. Okay, so now our passwords are set for our DataMover. However, our DataMover is not running. If we do a ps-ef and grep for DSM, we're going to see the only thing running is the Spectrum Protect server. So we want to start that DataMover. Now, an easy way to be able to start that DataMover would be to just type DSM-CAD, and that'll launch it, but the next time the box reboots, it won't be running. So we want to make sure it's running as a service. So in order to have it run as a service, the next step that we're going to have to do is configure through checkconfig, chkconfig, the auto start feature of DSM-CAD, and we need to modify the DSM-CAD auto start file. So during the installation, you will have gotten in etc initd a DSM-CAD file. There it is, and it calls back to rc.dsm-cad. So we're going to modify that. There's our old ones from our data movers that I never got rid of, our secondary data movers. So DSM-CAD, we need to edit. So I'm going to open that file up, and we're going to look in there. We see that inside here, essentially what this CAD does is it launches the CAD using the CAD directory of the default installation directory. So what that means is that there's nothing special being called. We're not referencing a dsm_config, which would change what options file we're looking at. So we're choosing the default options file to start the CAD. But there's a small detail that has to be added to this file that's not included by default. This feature is, or what you need to add is an export command for an environment variable for what's called LD library path. So I'm going to add that. I have that saved in temp, I believe. Yeah. And here's the line that we need to add. So we're going to go into the original DSM-CAD file, the one in initd. We're going to insert that line, and I want to tell you what's in this line. So in this line we say export LD library path, and then we pass it two variables or two parameters for additional pathing. The first one is the client installation directory, Optively TSM client BA bin, and then the second one is the Java runtime under Optively TSM Java runtime bin classic. Under there is a Java component that is needed in order to make the tag features work properly within the CAD. So if you neglect to add this line, when you attempt to start the DataMover, you're going to receive errors in your DSM error.log file. It'd be really nice if IBM integrated this automatically into the DataMover CAD file when they do the installation of Spectrum Protect for VMware, but they neglected it. So this is what you have to do. You have to add this line. This is called out in the installation guide, but I'm walking you through it here by hand. So that file is now added, and then we do standard stuff to add this into backup. So it's check config, I think it's add DSM-CAD. There we go. So now I have CAD set to on, which enabled at run levels 2, 3, 4, and 5, DSM-CAD will launch. So I can simply, once again, CAD's not running. We can do service, DSM-CAD start. Now it should be running. Okay, Now we can validate that the CAD is running properly by going to opt-tivoli TSM client BA bin. And we'll see we have some log files here. The DSM webcl.log is the first file that's written when you restart a CAD daemon, so we should see some content at the tail. There we go. Date and time is right now, essentially, and it said a command will be executed in 1 minute. So within 1 minute, we will see the scheduler get an update, and it'll pull for a schedule. I don't think we have any schedules set up, so we'll pull back and say there's no schedules available, but that's okay, not a big deal. We're going to go through and set that up in a moment or two here. So tail DSM webcl.log again, still waiting. Tail DSM sched.log. DSM, not TSM. There we go. No schedule returned from server. Scheduler's been stopped. So we've gone through. Took about a minute, and we have that that executed. So we know the scheduler service is set up. It's running properly. The CAD is set up properly. So all the essential components are working properly from the point of view of the DataMover and the web GUI for accessing the VMware backups. So I'm going to go back to the web GUI here, and now I'm going to refresh our configuration status. So from within the web GUI, under configuration, we can hit the refresh button here. It's going to go through and it's going to try to talk to all these different objects. We should get the same list of objects out, that refresh. Now, here, we got the password. Needs to be reset. So let's go back in here and let's set that password. I think the permissions may be set wrong after I made that change. All right, so under the data center, we see, remember I don't have the mount proxy mode node set up, but we can see that the data center DataMover was able to communicate. We see at last check DataMover VM data center DM is working properly. We can hit the validate button here just to confirm. We need to make sure that we see that the host name is populated, the address is populated, and the port is identified on the DataMover. We see it just refreshed. Everything looks green. So our DataMover is functioning properly at this point. Now if we go over to backup, if you've used Spectrum Tech for VMware before, this is where all schedules would normally be created. So you'd log in here, you'd go in and you'd start going through this exercise of creating a schedule. And there's this wizard. It asks you to check, type in a schedule. Let's just do test sched. And then right here is the thing that most folks have challenges with. So you uncheck this, open up this, and then we see cluster nodes from within VMware. We see objects, which are VMs, and we go and we can just check a few of these. We can attach them to a DataMover on the destination, set it up for a repeating schedule, and that's how that's supposed to be set up. But if you had, let's say, 1,000 VMs, this might be very difficult to do. And when you make a small change, you may have issues here. Also, there's some space, some text limitations in how many names you can add to a given job. So it forces you to create multiple backup jobs, and that may force you to create multiple DataMovers in order to run those backup jobs. All that adds up to a lot of grief. So IBM created an entirely new interface. So this doesn't need to be used anymore in order to set up your scheduling for backups. And I'm going to walk you through it. We're now in the meat and potatoes part of this video here. This is the part that I think everybody's probably been waiting for. Everything else has been pretty much normal setting up Spectrum Tech for VE. So I'm going to cancel out of this. And then under configuration, again, everything's good, everything's green. So now we're going to move over to our vSphere web client. And this is where we're going to start making some specific changes.